the process, where the process is decision-making around adaptation. Much of the science and many of the tools which are required for adaptation already exist. And indeed, given the uncertainties, we have to ask ourselves just how much more information end users can usefully assimilate and apply. So really, it's not about, for me, generating more information and about generating more tools. It's about proper communication of what already exists. Scientists need to listen to end users, they need to learn to speak the language of end users, and they need to learn how to communicate information usefully to end users. So, to bridge the chasm which sometimes seems to exist between science and end users who need the information that scientists generate, we need genuine intent on both sides. We need a dialogue, we need a common language, and we need patience. Thank you very much, Mr. Chairman.
Thank you very much, Professor Politico, for your presentation. And the feedback to me to be short, presenting the panelists. Ladies and gentlemen, next panelist is from AIT. Professor Sudip Rakshit, Vice President for Research of AIT. He's also leading our new Center of Excellence for Sustainable Development in the context of climate change. A few words about Professor Rakshit. Besides being active in creation of this new Center of Excellence for thematic research area of climate change at AIT, his research interests include biofuels, food and nutrition, food security, food safety, among many other areas. Professor Rakshit has been a resource person and consultant for numerous international organizations and private enterprises, and also lectured at international universities, and he has large experience as a keynote speaker and chair at international conferences. He has also published widely in both journals and books. Professor Rakshit, the floor is yours. 5 to 10 minutes, please.
Good afternoon. I do not have a PowerPoint presentation, so I'll use the microphone. I'd like to start my presentation by 2 or 3 quotations which many of us hear about adaptation. Number one is, let the negotiations go on, let's start the adaptation process. That's one thing we hear all the time, so especially from the affected parties. I heard this for the first time from somebody who's working in black carbon and the stress they have because of the melt of ice in the Himalayas. And we heard this morning another rhetoric, which was stop the rhetoric, start the action. Yeah. But having said that, I'd like to say that we have to be optimistic about it in the sense that scientists would lead the way. If you want me to paraphrase my presentation, I'd like to say that scientists, and here I mean technical scientists, social scientists, economic scientists, all together have to play a major role and decide that we have to work together to solve these problems. So having said that, I'd like to just touch on some of the subjects which some of my colleagues on the podium have already said, but maybe in a different language. I start with the vulnerability assessment, which is important for adaptation. And these are dependent on models used and methods of downscaling, as has been just indicated. We heard this morning, we have a lot of data, but we don't have enough data. That was what some speaker said this morning, and that's the case as presented by Professor Jean just now. All the data don't give it in the format she would like us to have. And looking at some recent publications, you would see, for example, last month, Stanford University had a paper which read, which they call Uncertainty Limits to Climate Adaptation. And they call it the greenhouse gamble. They had a roulette machine, and on the roulette machine they had different temperature levels, 1 degree, 2 degree, 3 degree, 4 degree, and said that we are not yet 100% sure about what it happens at the local level. So they're calling it a greenhouse gamble. They provided the odds for different increments of temperature rise, with the highest odds of 1 in 4 for 2 to 5 degrees centigrade rise in temperature. They went on to say that there is an expanding cascade of uncertainties for top-to-bottom approach for emission scenarios, beginning from carbon cycle response, emission scenarios to carbon cycle response, to global sensitivity, to region climate scenarios, and finally to range of possible impacts, cascading and widening, and hence not of much value if you put it in brief. In order to overcome this, we would have to identify potential focus areas of vulnerability using a bottom-up approach, as has been said. This may require a coupled bottom-up and top-down vulnerability assessment, and identify thresholds for specific regions. Adaptation has a clear difference from mitigation in the sense, the first point I'm making here is that the thresholds have to be calculated for different regions, coastal, polar, mountain, semi-arid, and then for sectors, meaning agriculture, water, ecosystems, coastal zones, and for different groups of people, old people, elderly people, women, indigenous people, etc. So it's a challenge for all to be working together. And that brings us to one of the core issues I would like to raise here, is that if you talk only about the science which is required, you just talk about the science which is required, you require technical scientists, you need a social scientist, and you need an economics person to be working together. These areas are not complementary or not near each other. It's not like chemical engineering and mechanical engineering where we can understand each other. It is between social scientists who has a particular mind frame, different from a carbon scientist like Dr. Netun, who's a chemical engineer. So that's just one part of the story. Scientists talking among themselves in what we call as a transdisciplinary manner is required. But adaptation requires beyond that. It has to be, different stakeholders are there. The scientists have to convince the policymaker. The policymaker takes an action which will change that. So those are different stakeholders there. On the ground, the local agents have to be convinced once the policy is changed. So beyond transdisciplinary, which itself is a problem, asking a professor of chemical engineering to talk to somebody from anthropology, we all know it's not easy for the two professors to understand each other. And then you add to that a politician, you have another mix. And I'm saying that these are some of the constraints which we have to overcome. Another dimension to the adaptation problem is the time frame. What is the time frame we are talking about? It could be real-time change. Some event happened in the north of Thailand. With all the models we had, this was not predicted. So what is the response is going to happen? The early warning system might have worked and told us that this is going to happen day before yesterday, and it happened yesterday. But do we have the mechanisms for connecting the technical know-how from the early warning system to the local agent through the policymaker and making that action happen? I can tell you there are lots of models which are working, some very good, interesting, successful stories in Philippines, for example, where this worked. The early warning system gave 4 or 5 hours of time, and local agents were quick to respond, saving more than 400, 500 lives. That's real-time, short duration. But then you have adaptation which might be long-term or also repetitive, happening like in Bangladesh, floods every year. What do? The agricultural scientist has to raise a rice plant which can survive 18 to 20 days under water. So completely two different time dimensions in the adaptation platform. I'm trying to differentiate a little bit from mitigation, where it is pretty straightforward stories. The relationship between scientific data and policy cannot be understated. When alternative choices are available, some decisions may boil down to an individual political choice, especially in the absence of indisputable data. I know of a colleague in Bangladesh who told me we have a number of possibilities to deal with a certain adaptation situation. But then we have to choose what the minister wants. And the minister might be also changing from time to time. And that is because we don't have indisputable data to guide the decision. So it's uncertainty data, as Professor Jean has just mentioned. So when in a situation of uncertainty, the government policymaker takes decision what he or she might think is the correct one. So to put that in words, you say strong so-called policy action on the other hand can reduce vulnerability considerably. So that's what has been shown in many cases, that if there is a good policy, you can do a good job of it. So that's a barrier there. Another aspect of it which we at AIT are just starting a project on is on technical needs assessment. Technical needs assessment for mitigation, very easy to do. Technical need assessment for adaptation, who do I call on to start the activity? Which scientist? A water scientist, or a coastal zone scientist, or an agriculture scientist? So who do I call on? When you're using mitigation, there you'll say use multi-criteria analysis, cost-benefit situation, cost-benefit analysis, and then choose the best technology you have. In adaptation, that's not really possible. Like I said, it will need all to sit together, put their heads together, and have tangible, indisputable data to say this is the way ahead. In fact, I was reminded about this when Achim Steiner, Executive Director UNEP, was talking to us this morning, and he said in adaptation activities, it's often felt that adaptation is a poor cousin of mitigation. And that is because we don't know how to hold on to when we want to do some of these adaptation activities. And like I said at the beginning of the talk, who to hold on means a group of people who will be willing to work together and have confidence in each other's work in a transdisciplinary way inside in the technical science community, and beyond that with the social scientists and the economists. Finally, taking this measure would alter conditions favorably to reduce vulnerability for different groups. But one should not address vulnerability just for the sake of climate change. Not just measures that are narrowly focused on climate impacts can broaden adaptation options and strategies. This approach, sometimes called mainstreaming adaptation, is used repeatedly. We heard it about 5 times today morning. But does it really work like that? Mainstreaming adaptation, what is the difference between development and climate issues? Is a broader issue which one might like to do, but that's the optimism which we have to keep while we're striving to achieve what we want to achieve. So I'd like to end by saying that in the case of adaptation, it is immediate. Like Dr. Nathun likes to say, it is now. Yeah? Urgency is now. The last time we were on a podium together, he used the slogan, the urgency is now. Yeah? For adaptation, the urgency is now. We don't know who the expert in adaptation is, because there is no single adaptation expert who can solve a problem like one could do with a solar collector in the case of mitigation. You need to have 3 or 4 people working on the ground together. And that is the challenge, working in transdisciplinary way with social scientists and economist scientists. Not my words, I'm not calling them economists, and economist scientists, to provide the technology and the services required for adaptation. Again, something which makes adaptation different from mitigation. It might not be only a technology, it might be a service which will change everything. Thank you very much.
Thank you, Professor Ekshid. Last but not least, I would like to invite Dr. Charles Rogers, Senior Environment Specialist, Climate Change Adaptation, Regional and Sustainable Development Department of ADB, Philippines. Dr. Rogers' areas of specialty include water resources planning and management, irrigation, and also agriculture water management, and global climate change impacts on water. His research and professional activities include climate change and flood frequency on the American River in California,